24 views on one of your videos.
Oh,
Whoa!
That was like,
Whoa, exactly.
good. 24. I'm famous.
just because you were
Okay, here we go. So this is now a rectangle because all four angles are right angles. It's a quadrilateral with all four angles being right angles. I challenge you to draw a quadrilateral with all four right angles, and it doesn't look like a rectangle. You can't, okay? It will look like a rectangle every single time. So if all four angles are right angles, that means the opposite angles are equal to each other. That alone says that now this is a what? Besides just being a rectangle, it's now a parallelogram. So, if it's a parallelogram, what else do we know about it since it's a parallelogram? We know that the opposite sides are, right? I'll do parallel in a second. Right, we know the opposite sides are equal to each other. We know the opposite sides are, now you can say it, parallel to each other. We already said that the opposite angles are equal to each other. What about the consecutive interior angles? What are they? They're supplementary. 90 plus 90 is 180. This 90 plus this 90 is 180, right? So they're supplementary. What if we threw some diagonals in there? Put a diagonal right here and a diagonal right here. Okay. So what do the diagonals do if this thing is a parallelogram? They bisect each other. That's right. They do. They bisect each other. Okay. So let's write down what we know about this. We actually only know two things as far as being a rectangle. Now, specifically since it's a rectangle, what do we know? We know all the angles are what?
90
Right. Yeah, 90 degrees. We'll just say, no, I was going to say right angles. Okay? You with me on that? So all the angles are right angles. All four angles are right angles. That's because it's a rectangle. So these are specific things because it's a rectangle. This is not necessarily true about every single parallelogram. This is only true about what? Rectangles, okay? So that means all the angles are right angles. Now here's something else. So we haven't said it yet, but you could almost guess. I'll give you a hint. Diagonals. Look at the diagonals. Now we know they bisect each other because it's a parallelogram, but they do something more specific in a rectangle than they do for every single parallelogram. What do you think? Just eyeballing. Yeah, they do. They look congruent, don't they? They look equal to each other. They absolutely are equal to each other, okay? So these diagonals of this rectangle are equal to each other. So let's jot that down. So we say that the diagonals are what? Equal. Or we can say congruent. All right, so the diagonals are congruent to each other. So what did we know earlier about the diagonals? We knew earlier that they bisect each other, right? Now we know, because it's a rectangle, now we know that the diagonals are equal to each other. So tell me about all four of these little segments right here. Right? From the corner to the middle, and so on. What do you think is true about all four of those? What do you think, Alan? They're all equal to each other, right? Because if you start off with two equal things, right? Both diagonals are equal. They're both being bisected, correct? So they're both being split into two equal parts. That means all of them are equal to each other. We'll put 3 tick marks. So all four of these are equal to each other. So that's kind of interesting. So what kind of a triangle do we have down here? Isosceles triangle, that's right. Okay, because you got two equal sides. You got two equal sides here, you got two equal sides here, two here. So look, this is isosceles and so is this. So is this, so is this. What else do you think might be true about this triangle here and this triangle right here? They're congruent. That's right. Give me a reason. Boom. Boom. Side, side, side. Okay, watch. I got these two sides and this one. I got the same two sides and the same side here. Okay, so they're congruent because of side, side, side. Same reason with these two triangles right here. They're congruent to each other as well, aren't they? So if you want to think about this, look. See how this angle right here has to equal this angle, right? These two sides are equal, aren't they? It's isosceles, so the opposite angles are equal to each other. And this is congruent to this, so guess what? All four of those angles are equal to each other, aren't they? There's a lot of stuff now we could tell that's true about this, couldn't we? Make sense? All right. I don't know if they're even going to get into that, but I don't know. I just saw it. I didn't say that in the first class. I just kind of saw it here and went with it. All right. Let's see. You know what? I think we're almost done. I told you it was easy.
A 6-minute lesson?
The best class ever.
Let's do this, though. Watch. Now, we started off knowing that it was a rectangle. So we said, if it's a rectangle, then the diagonals are what? They're congruent to each other, okay? So we said, if it's a rectangle, then the diagonals are congruent. What if we just had a parallelogram where we knew the diagonals were congruent to each other? Then we could say it's a what? So if I have a parallelogram and the diagonals are congruent, then it's a rectangle. You with me on that? So look at page 420. There's a theorem. It says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if I know I'm starting off with a parallelogram and I know the diagonals are equal to each other, then I can say that that parallelogram is not just any parallelogram. It's what kind? It's a rectangle. Make sense? All right. So this is the first of, I think, 2 lessons. Let's see the third one, right? The third one's not a parallelogram. But this lesson and tomorrow's lesson are special types of parallelograms. So the first one is a rectangle. Just off the top of your head without looking, what do you think the next one might be? A square, that's right. That's what we're going to do tomorrow. And there's another one that you may not be as familiar with, and it's called a rhombus. That's right. So we're going to do square and rhombus tomorrow. All right? But today we'll just do the rectangle. Pretty easy stuff. You want to do a quick example here before we finish this up? All right. Good. Let's do one. Yeah, we got time. So here's a rectangle. Let's put some diagonals in this rectangle. There. And this is just taken right from the book, page 420. That's J, P, K, and M, and L. All right, here's what they tell you. They tell you that angle KJL is 2x plus 4. This isn't really all that hard. And then JLK, angle JLK, is 7x plus 5. Alright, and it says solve for x. So let's find these angles in here. JKL, where's JKL? JKL. Oh, is that right? No, it's not. It's KJL. I can't read my own writing, okay? It's KJL. I knew I didn't want JKL. It's this angle right here. This angle right here is how many degrees? 2x plus 4, right? 2x plus 4. And then it says JLK. Let's try to get this one right now. JLK. That's this one down here. Okay? This angle. That's 7x plus 5. This isn't hard at all. Now, they tell you it's a rectangle. They tell you JKLM is a rectangle. There's no symbol for rectangle. All right? So we just call it rectangle JKLM. And you write the word out, rectangle. And we want to solve for x. So what do? Do you set them equal to each other?
No.
Seems like we always set stuff equal to each other. Not in this case. Now, I've told you that this is a rectangle and I want to solve for x. So what does that mean? It means this angle is 90 degrees, which means we have a right triangle. What's true about the non-right angles of a right triangle? They're complementary. Right, they're complementary. Right? Because we know this is 90 degrees, right? So you take 180 minus 90 is 90, so these two must add up to be 90 degrees. Everybody see that? Okay? That's what you do. So the math is easy once you figure that out. So 7x plus 5, oops, not equals, plus 2x plus 4 equals 90. Let's see, that's 9x plus 9. Subtract that from both sides, so x is what? 9. There you go. Now they could ask you to find the measure of J or KJL, couldn't they? If they did, that wouldn't be a big deal, would it? Actually, you could find every single angle in here, couldn't you? If you wanted to. So what would this angle right here be? So it's 2 times what? 9, which is 18, plus 4, which is 20, or yeah, 22. I was gonna put 44, I don't know why. So if that's 22, what do you think this angle right here is going to be? Without doing any math at all. What is it? 22. Remember these two are equal to each other. The opposite angles are equal, okay? Because it's a rectangle. That's 22. What would this angle right here be? It's MJL. What is it? 90 minus 22, which is what? 68? Yep, so that's 68. If you get that, the rest is pretty easy. What's this one without doing any math? 68. What's this one? 22. See how easy it is? 22. What's this? 68. This would be 68. What about this? Let's do this one right here. What's that one going to be? I don't know. What's that? That's 120, 136. And then 180 minus 136 is 44. Does that do that right? 44? I think it's 4. Try it. 180 minus 68 minus 68. I think it's 44. Okay. All right. And then what's this one right here? That would just be whatever these two are. 136, right? Okay. And then that's 136, and that's 44. I told you we could find every one of them, couldn't we? All right. So there you go. Now, I probably won't have a question where I ask you to find every single one of those, but you never know. All right. You never know which ones I ask you to solve for. It wouldn't be hard at all. We good? All right. That's it. Let me give you some. Let me give you some homework.
I know.
A 5-minute example.
Because I remember you were asking Chris if he was like awake or something.
Oh.
And you told Matt to like calm down.
Told Matt to calm down?
Yeah.
Why? What were you doing?
I don't
know what I was doing.
I don't remember telling him to calm
Or
down.
not calm down. You told me like Matt. Are you paying attention?
I'm always paying attention.
I probably did say
And you're
that.
like, yeah, look, I'm taking notes.
I did?
Yeah.
Are you watching my lesson?
Yeah.
You have a flyway, Gabby.
6.
Giant knot.
All right, there we go. There it is right there. Write it down. 10 to 19, 26 to 32.
No!
It's not that much.
No. 19, 20. Odds?
All.
Okay.
Everybody got it? 10 to 19, 26 to 32. All right, section 6-4. All right, that's it. Everybody want to say bye?
Bye. Later.
Be free.
That was weak.